So here we go. 5-step process for finding extrema. So step 1, you're going to find your domain. Step 2, find your endpoint, if there are any. That's what's going to tell you if EVT holds. If EVT holds, then you are guaranteed an absolute max and guaranteed an absolute min. If it doesn't hold, you could end up with one or the other or both, but you're just not guaranteed them. Third step, find your derivative, set it equal to 0, and take that same derivative and make it equal to undefined. Step 4, make a sign chart. And then step 5, you want to label your max and min. Check for absolute. And then give reasoning. So I'm going to use that process for the next few problems. The first problem here was actually from your 4.1 quiz. You were just asked to take the derivative. Now I'm going to actually find the maximums and minimums. So I'm going to do your first step, which is domain, which is kind of a pain for this problem because we have an ln, we have a square root, and we have a fraction. We got a lot going on. So let's start with just finding what is the innermost function. So that's the root of x. So I'm going to take that x inside, whatever's inside the square root, set it equal to 0. So that makes it really easy. We're going to get, when you put 0 into the square root, you end up with 0. Okay. We're going to put the values here into just x. And so this would give me negative values, this would give me positive values. So if I'm really looking at the square root of x, you're allowed to use positive values and 0. The reason why I'm not going to use 0, it would cause the fraction to be undefined. So far, just with that piece, that's the domain of just 4 over the square root of x. So now I'm going to actually look at the ln. So we're going to look at, does the ln restrict it any more? Meaning, the ln of 4 over square root of x. So is there another restriction on top of just the 4 over square root of x? So the restriction is that in here we're not allowed zeros and we're not allowed negative values. So I'm going to take that fraction, set it equal to 0. But we get this. So that actually never will equal 0, which is nice to know. We already have that. We have no extra restriction. How do I know that? I know there's no extra restriction because we didn't get any values here. And secondly, I know that when I take the ln of 4 divided by a positive square root, you're allowed to do that, meaning you're going to be taking the ln of a positive number. So my domain is literally what is right here, 0 to infinity. Means in step 2, for endpoints, there are none. All right, so part B would be, we did step 1, domain. We did step 2, endpoint. Step 3, find your derivative. Now the derivative work here can be a little bit confusing because we're going to rewrite this function as x to the negative 1 half. So here we go. So we have that the first derivative would be 2x plus ln's derivative is 1 over u times the derivative of u. Now I'm going to bring that power down and I get negative 2x to the negative 3. All right, so now we're going to write this a lot neater, make it look nicer so that we can actually do something with it. All right, so all these weird negatives. First of all, I have that negative 2 in the numerator. I have the 4 in the denominator. Secondly, this power is negative, so it has to come down here. This power is negative, so now it has to move up here. So we end up with 2x minus x to the 1 half over 2x to the 3 halves. But the way that I deal with my powers, I look at who has more x's, and that's the denominator. I have 1 half versus 3 halves. Who has more 3 halves by how much? By 2 over 2. So the way that I would rewrite my derivative is 2x minus 1 over 2x to the 2 over 2 power. So that's 1. The other way you could have done that is you would end up with x to the 1 half minus 3 halves. Gives you x to the negative 1 half and then, negative 2 over 2 in the numerator, which then makes it move downstairs. Alright, so we get multiply 2x over 2x to get the common denominator, and we end up with 4x squared minus 1 all over 2x. So I'm going to factor that, and I get 2x minus 1 times 2x plus 1 all over 2x. So set my derivative equal to 0, and I would have 2x minus 1 times 2x plus 1 equals 0, x equals 1 half and negative 1 half. I get f prime is equal to undefined, which would be the denominator equal to 0, which x is equal to 0. The domain was that x is greater than 0, so that is actually not a value that we can use to find max and min. So here's 0. This value can't be used because we're supposed to use x is greater than 0, and we found that in our domain. So here's my 1 half. I'm going to put my 0 here. This is undefined because it's not in the domain. Oh, and on top of it, it's not in the domain. I'm going to use the value of 1/4 right here. And 1/4 would cause this to be negative, this term to be positive, and this term to be positive, which is a negative. Put in 1,000, and I would have positive times positive divided by a positive. So here we go. We have a minimum right here. And my reasoning would be, I'm going to squeeze it in, f prime of 1 half equals 0, and f prime changes negative to positive. All right, so that would be what I would make you do after finding the derivative. And now you see why I really wanted you to get that common denominator and then to factor, because it makes the sign chart a lot easier to do. So that's step 5 I kind of snuck in right here. All right, last problem. From your quiz, I'm just going to walk through this one more time in case you need it. We get that I'm going to do the 5-step process. So domain. There are no problems with the domain. We have a 1/3 power, which is odd over odd. We have x squared, which is not a root. So our domain is all real numbers, which means that step 2, your endpoint, there will be absolutely none. Step 3, f prime of x. Taking the derivative, leave the first one, multiply by the derivative of the second, minus, leave the second one, derivative of the first, and we get 3 times 1/3 x to the negative 2/3. I'm going to simplify this and get 6x to the 4/3. How did I get that? I got 3/3 right here. Minus, let's see. The x squared minus 14, I'm going to use as my numerator. And then the x to the 2/3 is going to come downstairs. Now I'm going to multiply so that I can get a common denominator. X to the 2/3, x to the 2/3. And we get 6x to the 6/3, which is squared. I'm going to add those. Common denominator was actually 2/3. I'm just going to write that in. And I have minus x squared, but I'm subtracting this whole term. So you want to be careful and have the plus 14. I'm just double checking if by any chance I might have made the mistake of, there it is. That should be a plus. Found it. All right, so that should be a plus. And that would be a plus, which would change this back to the minus. Sorry about that mistake. You probably saw that earlier and were wondering what I was doing. Okay, so now I get 7x squared minus 14 over x to the 2/3, which gives me 7 times x squared minus 2 all over x to the 2/3. So if you remember in this one, because we have domain all real numbers, endpoints none, EBT doesn't hold. So I'm not guaranteed anything. I might have something, but I'm not guaranteed. So I'm going to take this to the next page. I'm going to use the derivative and set it equal to 0 and undefined. So I'm still in step 3, continued. F prime equals 0 would take the numerator. Set it equal to 0, and we get x squared minus 2 equals 0. X equals plus or minus the square root of 2. Just to save a little room, I'm going to do f prime equal to undefined, which means x to the 2/3 equals 0, x equals 0. So now we can do our sign chart. Step 4, sign chart. Now remember, the domain was all real numbers. I'm doing f prime sign chart, so we're going to do negative root 2, 0, and root 2, 0, 0, undefined. Nothing's crossed out because the domain was all real numbers. Now, we're going to look at that term. It's always positive because of the squares. This is what makes it always positive. So because of that, I'm only going to use 7 times x squared minus 2 to do the sign chart. Now I'm going to do the sign chart in a really easy way. We know what this graph looks like. It's a parabola facing up. So with zeros at negative root 2 and positive root 2. So I'm going to draw that in green, and then you can see the signs would be positive, negative, negative, positive. If you don't know that, you would use a number 1 here, you would use negative 1 here, you would use something like a negative 100 and a positive 100. There's your sign chart. Now, looking at the sign chart, I'm going to move this out of the way. We can see that the graph goes up, flattens, down, does something weird, goes down, flattens, up. So we have a max here, and we have a min here. We don't know if anything's absolute, because if you think about it, domains all real numbers, and those ends would keep going. So we don't have any absolute. But I know that x equals negative 2, so this is step 5, is a max, because f prime of negative root 2 equals 0, and f prime changes plus to minus. I know that x equals positive root 2 is a minimum, because f prime of positive root 2 equals 0, and f prime changes negative 2 positive. So the one thing that I wish I had done is given you one where you'd have to make the table. So you see a number, or the step 5, I haven't made any tables, and that's because I didn't have any absolutes. So in this problem, there were no absolutes, so I didn't have to compare any y values. You only compare y values when you have to figure out which is bigger. If they're asking for absolutes, then you have to find your y values. In this case, I didn't need to, so in step 5, there's no table of y values. That should be everything.